Welcome back to All This Math. This is Professor Parker, and for this next lesson, we're going to be talking more about dirt bike math, and we're going to be talking about gas-oil ratios. All right, gas-oil ratios. But before we do that, I want you to take notice of who I got on my chest, on my T-shirt. This is Rosa Parks, the late great Rosa Parks. Please do your research about her. I know her name is brought up a lot during Black History Month, but the full story has not been told. It usually is not told in public schools and charter schools and even in private schools. So please go do your research on her, do some reading. All right. There's some books available about her. There's actually a documentary which references a lot of the information that is available in books about Rosa Parks, which is available on Peacock. It came out earlier this year. This is 2022, by the way, when I'm recording this. So yeah, but definitely I want to shout out the ancestor Rosa Parks, involved with the Montgomery bus boycott back in 1955, and also she was involved in civil rights activism even before the Montgomery bus boycott, and after that she was involved in civil rights activism. She actually was down with the Republic of New Africa, which was news to me. That kind of excited me because I'm, I got love and respect for the Republic of New Africa. So that's another organization and another formation that you also should check out if you never heard of the Republic of New Africa. All right. So at any rate, let's get into the math now. We're going to do more dirt bike math, and we have a word problem behind us. I've done several problems similar to this, where I just basically change up some of the information so that we can come up with different calculations based on the different numerical information provided. So let's read it. Let's read it. On your two-stroke bike, your gas-oil ratio is 32-1. How much oil should you put in to the tank off 3 gallons of gas? All right. So you got to mix the oil with the gas. You got to mix the oil with the gas, but you got to mix it in a certain type of way. And the way you mix it is dictated by mathematics, a mathematical ratio, 32-1, a 32-1 ratio. All right. So that's how much. So for every 1 unit of oil, there should be 32 units of gasoline. If the mixture is not set up like that, that's going to cause problems to your engine, and you don't want that, right? You don't want your engine to get all messed up, all right? Because that could be expensive to repair or equally expensive to just have to buy another dirt bike. All right, so this is how math can help save you money. Knowing math and understanding the math can help save you money. And even if you don't apply this to this situation, knowing how to solve problems that involve ratios is just a good skill to have. It's a good skill to have no matter what the content of the situation is. All right, so what we're gonna do is we're gonna figure out how much oil. We need to know how much oil we need. Now, how do we measure oil? This is what we're gonna do in this particular problem. I haven't done this in any of the other videos yet, but we're gonna find out how much oil we need in ounces, and then we're gonna also figure out how much oil we need in milliliters, right? We're gonna take it, we're gonna get metric with it. We're gonna go metric with it. We're gonna go from ounces to milliliters. But first, we're gonna figure out how much oil we need in ounces. In order to do that, first we're gonna figure out how much oil we need in terms of gallons. We're gonna do gallons first. We're gonna go from gallons to ounces to milliliters. Gallons to ounces to milliliters. And we can do all that pretty easily. I'm gonna show you how to do it. So first, we're gonna set up a proportion. Now a proportion is just an equation that has 2 fractions in it. It could have more than 2, but in most cases, you'll have 2 fractions. So our first proportion is gonna be a gas-oil proportion. So it's gonna look like this. Gas over oil is equal to gas over oil. All right, and I draw my arrow because we're gonna write something after that. So gas over oil equals gas over oil. So my first fraction can include this ratio right here, 32/1. 32/1 is the same thing as 32/1. Now, how do I know that this 32 goes with gas and this 1 goes with oil? Because look at what it's called. It's called a gas-oil ratio. So the gas is first. This first number represents the amount of gas. Oil is second. This second number represents the amount of oil. All right, that's how we know. So we go left, right, top, down. First, top, first, top. First matches up with the top. So we got 32/1 is equal to this fraction right here. Now, what's in that fraction right there? In that second fraction, what we have is where we have the amount of oil that we're trying to figure out. We're trying to find out how much oil we need. And also we have 3 gallons of gasoline. So we put the 3 on top because gas is up top, right? We don't know how much oil, so we use a variable to represent that. So this is my equation. right? Once you got an equation, you in a good space. You're in a good space, right? You got an equation. Now you just need to know how to solve the equation, all right? Now the way you can solve, one of the ways you can solve a proportional equation is you can use something called the cross product property. The cross product property means you look at the numbers or terms that are diagonal from each other, like diagonal, same way like how a lot of people will cut sandwiches diagonal, right? And you multiply those terms. So you're gonna do 32 times x, and you're gonna do 3 times 1. All right, now what's that gonna look like? That's gonna look like 32x is equal to 3, because 3 times 1 is 3. So 32x comes from 32 times x, 3 comes from 3 times 1. When you're doing math problems and you're doing equations, you want to always understand where these numbers be coming from. You got to know where they came from. Like, where did this 3 come from? 3 times 1. Where did 32x come from? 32 times x. Why is this 32 right here? Because that ratio says gas to oil is 32 to 1. That's why the 1 is right there. Why is this 3 right here? Because the problem told us we're dealing with 3 gallons of gas, and gas is on top, oil is on the bottom. Why is this x right here? Because I don't know how much oil I got. That's what the whole purpose of doing the problem. We try to figure out how much oil we need, so that way we put in the right amount of oil and we don't mess our engine up, because you don't want to mess your engine up, right? Because that's an expensive repair, or you might have to buy a new bike. All right, so now 32x equals 3. How do I solve for x? I got to get rid of this 32. How do I get rid of the 32? You get rid of it by doing the inverse, what we call the inverse operation. The inverse is the opposite operation. 32x means 32 times x. The opposite of multiplication is division. So I got to divide. So I'm going to divide this by 32 right here. And then because it's an equation, I got to stay balanced with it. You got to stay balanced. If I divide by 32 on the left side, I got to divide by 32 on the right side. Divide by 32 on the left, divide by 32 on the right. So over here, we do this. 32 divided by 32 is 1. That's 1x. 1x is just x. And then I'm going to do 3 divided by 32. 3 divided by 32. Now I'm going to break out my calculator right here. My little, you can grab you one of these. If you don't have one, you can get them. They're not that expensive. You can get them online. You get them from the store. It might cost you like $12 or something. It's an excellent tool. Try to use these and try not to use your phone calculator unless you absolutely have to, because your phone can be distracted. All right, stay focused with just this, right? So we got 3 divided by 32. That is a decimal. It equals 0.09375. So this is how many gallons. This is how many gallons. This is a very small amount, right? But like I said, we want to convert this into ounces. Like I said, we're going to go from gallons to ounces to milliliters. Gallons to ounces to milliliters. Gallons to ounces to milliliters. All right, so that's how many gallons of oil we got. 0.09375 gallons. That's a very small amount, and that's why we're gonna convert that to ounces, because an ounce is a better unit, better representation of the amount in terms of units, right? So how do I do that? How do I convert from gallons to ounces? I got to know a little bit about the unit conversions and the unit equivalencies, right? So I know that 1 gallon, this is information that you should memorize, right? This is information that you should memorize, right? 1 gallon is equal to 128 fluid ounces. So I'm gonna have another proportion that's gonna look like this. This is one way I could write it. Gallon over ounces is equal to gallons over ounces. And then I'm gonna write my equation. Now 1 gallon is equal to 128 ounces. So my first fraction is gonna be 1 over 128. 1 gallon, 128 ounces. 1 gallon, 128 ounces. These are equivalent. The amounts, equivalent, different numbers, but equivalent amounts. Because 1 gallon, these are not gallons and gallons. These are not ounces and ounces. 1 gallon is the same amount as 128 ounces. So then in this fraction, I'm going to include this information right here so I can figure out how many ounces is equivalent to this many gallons. This many gallons is equivalent to this many ounces. And now I want to know how many ounces is equivalent to this many gallons. So I'm going to set up another fraction, right? My gallons go on top. So this decimal goes on top, 0.09375 over x. Now I'm not going to use x because I already used x. I'm using a different variable. I'm going to use y. Now I know I'm talking kind of fast, but if you don't understand something I said, feel free to pause and rewind. That's the beauty of the technology. Just pause and rewind, run it back, all right, to get a better understanding. All right, so this is 1 gallon, matches up with 128 ounces. this is 0.09375 gallons, matches up with the amount of ounces that we're looking for. We're trying to figure out how many ounces is that many gallons equal to. I use the same method that I used up here, cross product property. Math is all about rhythm. Once you get into the rhythm, you understand the methods and the formulas, you use the same thing over and over again. It's a rhythm, right? Just like doing the dance. You do the same moves over and over again. The same old two-step, same old three-step, whatever, whatever you're doing. All right, whether you're doing a park height strut, any of that. It's the same moves over and over again, right? So we do the same thing with math. We use the cross product property up here. We're about to use the cross product property down here. We're gonna do it again. All right, so we cross like this, and we cross like this. So that's gonna be 1 times y. 1 times y is y equal sign 128 times 0.09375. Y equals 128 times 0.09375. All right, now when we multiply them two together, I'm about to grab my calculator again. Hold up. I take this and multiply it by 128. That's gonna give me 12. So now I got Y equals 12. And I know it's ounces, so that's 12 ounces. So I said I was gonna find out how many ounces that is. So if you got a tank that holds that much gas, first of all, a lot of tanks don't hold that much gas. But if your tank holds 3 gallons of gas, with this ratio, this 32-to-1 ratio, you need 12 ounces of oil. You need 12 ounces of oil. That's how much you need, 12 ounces of oil. Now, I also said at the beginning of this video, we was gonna also convert into milliliters. Milliliters, we're gonna take it to the metric system, all right? A lot of places in the world use the metric system. Even if you buy a bottle of oil, you're probably gonna see the measurement, not only in ounces, but also in milliliters, the entire measurement or the capacity of the entire container, all right? So we're gonna go back to another proportion. So we're gonna do this. Let's do ounces over milliliters. Well, is equal to ounces over milliliters. So I happen to know that 1 ounce is equal to 29.574 milliliters, roughly 30. But I'm gonna try to be more precise, right? So 29.574 milliliters. So 1 ounce, that's my first fraction. It's gonna be 1 ounce is the same as 29.574 milliliters. 1 ounce equals 29.574 milliliters, right? Now, my second fraction includes my unknown values, my unknown information. So I know that I'm trying to figure out how many milliliters is equal to 12 ounces. I know that 1 ounce is equal to this many milliliters, but how many milliliters is equal to this many 12 ounces? So I know 12 is going to replace the ounces. I'll throw the 12 up top, and the milliliters is what I don't know. That's my unknown. So I pick a variable for that. Now I already use X, I already use Y. I might as well keep it in alphabetical order and just use Z. So might as well do, right? Again, the rhythm. Cross product property up here, cross product property right here. Cross product property again, right? So we're going to do that again. So watch this. 1 times Z, 12 times 29.574. 1 times Z is just Z. And then 12 times 29.574. It's going to be something like, watch, it's going to be something like 360. Watch. It's going to be something close to 360. You know how I know that? Because 29.574, if I rounded him up, that would have been like 30. 12 times 30 is like doing 12 times 3, which is 36. But then attach that 0 to the 36, you get 360. So that's going to be close, right? So Z is equal to how many milliliters? 12 times 29.574. Yeah, I was close. Yeah, 354, because I know it's going to be less because I rounded up to 30. So my value when I round up to 30 is going to be overstated. All right, overstated. It's going to be more, right? So the actual amount is 354.888. So let's round him to like 350. Let's say approximately 355. 355 milliliters. Because that 8 is going to make this 4 go up and become a 5. If I round it to the nearest milliliter. This the ones place. This is an 8 to the right of it. Any number, just a little refresher on rounding. Any number 5 or greater, you give it a shove. This is greater than 5, so this 4 is going to go up and turn into a 5, giving you 355. If this number in this place right here, this 10th place right here, was a 4, a 3, a 2, a 1, or a 0, this would stay what it is. We would basically round down to 354. Round down to 354.0. Because when you round it, you only got 2 choices. You're either going to go up to the next higher number, or you're going to go down to that number. So we either go down to 354 or go up to 355. 2 choices. Because that's an 8, we sliding up to 355. That's what we doing. But look, check it out though. With this ratio, if this the manufacturer recommendation for the ratio between the gas and the oil, and you put 3 gallons of gas in the tank, this how much oil you need. Either 12 ounces or 355 milliliters, no matter how you're looking at it. 12 ounces if you use the, I guess that's what they call the Western system or the U.S. Imperial system. I'm not sure what the name of this measurement system is. I think it's the British Imperial system. I think. I could be wrong. I need to research that. But here, this is definitely metric system, milliliters. All right, so we got 355 milliliters or 12 ounces, either way. But notice, but the important thing is like the methodology, like how did we get the answer? Like how did we get the answer, right? We did the same steps over and over again. We set up a proportion. We set up the words, right? Replace the words with numbers and a variable. Then we did cross product property. Then we solved the equation, right? We got that. We got this many gallons. I didn't want it in gallons. I want to know how many ounces. So I set up another proportion, comparing gallons to ounces. I do the same thing. I get 12 ounces. But then I was like, let's figure out how much it is in metric terms, right? Using the metric system, right? So let's set up another proportion. Let's do ounces to milliliters. Let's compare ounces to milliliters. I know that 1 ounce is the same thing as 29.574 milliliters. Some people will round that up to 30. That's cool too if you want to, right? And you set up the proportion. Just set him up. Replace the words with numbers. Replace the words and the symbols with numbers. 1 ounce, this many milliliters. Then I knew I had 12 ounces, so I want to know how many milliliters is that. So that's why I keep a variable right there. Then I do cross product property. Then I simplify. Now with this one, it was just Z times 1. Z times 1 is just Z. So therefore, I didn't have to divide anything on both sides. I just did straight multiplication. And I got my answer. So these are my 2 answers. This is how much oil you need in ounces. This is how much oil you would need in milliliters. All right. So use this video as a guide. Create your own examples to get more practice, or find some examples online, or ask somebody for some examples. All right. But the point is to get practice. Get practice so you can master the skill. All right. Use the video as a guide, and I'll catch up with you on the next video. Peace.